Special thanks to E equals MC squared for creating this video. Today on Tucker Time, we're going to do a single teaspoon reaction.
What we're going to do is we're going to have copper sulfate and we are going to mix iron filings with it. The iron will take the place of the copper. So we will put this in as our metal and we will end up with this. That is copper at the bottom of the sulfate.
The water looks like
it'll start out blue. When we add this, it turns murky. It's kind of cool. This is a fun one because like you can actually see the copper falling out, kind of like that dichotomy. We're going to start with, we need to mix this stuff together. So there's that. I have 50 milliliters of water.
Remember, like when I go, it's going the other way.
Right. Alright, so we're going to add 50 milliliters of water to this. Okay, we're going to get all of it. Now we've pre-measured out 8 grams, 8.00 grams of copper sulfate that we will just add to this. Alright. And here, you want to stir that in. And because it won't all dissolve on its own easily, what we're going to do is we're going to pull out our burner and our ring stand. And we're just going to heat it up because generally when you heat something, it increases the solubility, so more of the copper sulfate will dissolve into the solution, which is ideally what we want for this reaction to occur. So if you can just set that up on there, and we'll start our burner, and we're going to just heat it up so that all of that, like you can see this copper solution, copper sulfate at the bottom, we want that to dissolve so it's all liquid. We'll test that out. Yeah, we might have to. Because we don't want it to boil, we just want it to get a little bit warmer. We want to keep an eye on it because what we want to do is we want to heat it, but we don't actually want to boil it. That's copper sulfate. We're going to mix iron with it to see if we can remove the copper from the solution, because copper right there is an ion and it is obviously a liquid and not as a metal form, a solid form, and we want to get solid copper out of this. You might have to stand up a little closer, but you can see when we put the paper on, there's a weight. It says about 0.13 grams. Can you see it now? Because I think you're looking at it from an odd angle.
Oh, yeah. Oh, it's like 2,000. What happens if you press the T?
Okay, go ahead and push the T button. The T button is tare, and when we're talking about scales, that just means I've told the scale, ignore the weight of that paper. Because when we're weighing stuff out for chemistry, we want to make sure that we are only weighing the chemicals that we want and nothing else. And I don't want to boil it, we just want to get it warm so that everything dissolves. Have you ever done that with sugar and you can make rock candy?
No, but I did holographic chocolate. Today on Tucker Time, we're going to make holographic chocolate.
I did see that one, that was really cool. So what we do here is we are going to dump just a little bit of this out because we only want about 2.2 grams. So these are our tongs, we always use those for hot stuff so that we don't burn ourselves.
Can I just put them? I am the expert.
You're the tong master.
Yes, I am the tongue expert.
So the next thing we're going to do is measure about 2.2 grams of this. So if you want to take this scoop, I know it's a tiny scoop, but we don't need much. So if you want to scoop just a tiny little bit on there, we don't want to get too much. And you can see how slow and careful Tucker is being with this. If we take too much, we can't put it back in because we don't want to contaminate any of our stock solutions or our stock of anything. So we try and take it gentle and just a little bit at a time. Chemistry is sometimes more about precision than it is about speed. There we go. 0.24. Yeah, definitely stir that. That's why I have you here. You're helping me out.
I once by accident got burnt by dry ice. Imagine that! That would even hurt more!
It's also at the boil, so we're going to turn the flame down because we don't actually want it to boil. I think we're probably good. I think it'll work now. So if you want to turn off our burner. Probably, but I can't feel it because of the pot holder. So you can see we've pulled this off now, and it looks like everything's dissolved, right? Do you see anything left in there?
No, I don't think so. There's like one particle.
So we're going to take this. You want to dump the iron filings in? You probably want 2 cans because we want to get the right amount in. Yep, just pour it right in there. And we found it here. Yep, all of it in.
Stir it.
Yep, and now we're going to stir it. You can see it kind of turns murky.
Ew. Whoa, wait! It's already making copper! It's already making copper!
That's what we're going to do is we're going to give this reaction about 10 minutes to keep going. We will edit out the 10 minutes, but you could see where like the copper just instantly started to fall out of solution. And it kind of gives you an idea of why at points in time people believe in alchemy.
And also, this is turning green.
Green, yeah. So we've waited about 10 minutes. You can see we've got a good amount of copper. So you might be wondering, how are we going to get rid of the water? What we're going to do is decant it here, which basically means we're going to try and pour it down our stirring rod, because what we want to do is just, and obviously I'm doing such a great job with this. What we would like to do is just get rid of the liquid and not lose any of the copper. You want to give it a try? Face.
The bottle's still
The bottle's still a little warm, so you want to be careful at this point. As you can see, we're getting rid of all this water left. What we should be in there is iron and sulfate, and what's left with on the bottom is copper. If you look, you can see we've got a lot of copper here. What we want to do is we're going to add just a little bit of water to it and rinse it and dump it again. And then we just let this dry and get rid of all the water, and you're left with a large amount of copper. I'm not sure exactly how much is in there, but I would guess probably 7 or 8 grams. You want to rinse it again?
Yeah. Get nice and clean. We've now answered the burning questions of Tucker.
Let's be clear. It looks like mud.
It does, doesn't it? We'll put it in a bag for you to take home, but basically you want to let it out to the air, and then all this water will evaporate off, and then you're left with basically a pile of copper that you can show and impress your friends with.
Wait, the paper isn't wet.
Yeah, it's parchment paper.
Oh,
It's like got that wax coating that prevents the water from absorbing into it.
well, what happened with the effects back? Remove the blob.
Surface tension. What we saw was a single replacement reaction in which the iron filings take the place of the copper, and so the copper goes from solution and changes its state and becomes a solid, which is what we have here. It's a fun experiment to do, and it's really cool because you can see the copper forming, right? And you can play with it after.
Yeah,
Get back in now.
thank you.
This was fun. Hope we can do it again.
I hope you enjoyed my video today with Melody. And remember, smash that like button, ring the bell, follow me on social media, and check out E=MC² to see what my friend Melody does. Bye! Wait, how about you do it real quick?
Okay.
Bye!
Bye.
Thanks for watching Tucker Time! To find out more about E=MC² and what they do, go to unlockyoureducation.com.